So in one of the previous lessons, we had learned about what are matrix inverses. And in this lesson, I want to take you through a process known as the Gauss Jordan elimination method for calculating the inverse of a matrix. And I think this method is best illustrated by an example. So let's say I want to find the inverse of a matrix A, where let's say A is equal to 3, 0, 2 and 2, 0, minus 2 and 0, 1, 1. All right. So we begin this method by writing down A, and then we write down the identity matrix right next to it. So we write down, let me write down the matrix first. So it's 3, 0, 2, 2, 0, minus 2 and 0, 1, 1. And then we put a bar like this in front of the matrix, and then we write down the identity matrix. So that's going to be 1, 0, 0, 0, 1, 0 and 0, 0, 1. All right. And now what we have to do is that we have to turn the matrix, that is A here, and this is I, right? So what we need to do is to turn the matrix A, okay, into an identity matrix. All right. So the goal would be to have only diagonals ones in the matrix A, and rest of the elements have got to be 0. And the way we accomplish this is via means of elementary row operations. All right. So I think by now you already know what elementary row operations are, but just to quickly summarize, using elementary row operations, A, you can swap rows, okay. B, you can multiply. So you can multiply a row by any constant. And C, you can replace. So you can replace a row by adding or subtracting a multiple of another row to it. All right. Okay, so now we start the process of Gauss Jordan elimination. So we write down the matrix A, and then we put a bar, and then we write down the identity matrix. And the goal is to convert this A here into an identity matrix. Okay. So to begin with, I see that there is a 2 here. Okay. I need to get rid of the 2. So what I'll do is that I'll actually add row 2 to row 1. Okay. So I'll I'll replace row 1 with row 1 plus row 2. And this will give me 5, 0, 0 and then 2, 0, minus 2 and then 0, 1, 1. And on the right side, if we add row 2 to row 1, we will get 1, 1, 0 and then 0, 1, 0 and then 0, 0, 1. Okay. Trying to be extra cautious here so that I do not make mistakes here. So all right, that sounds good. Okay. So now the next step. So now what I see is that we have a 5 here, right? And I really want to get rid of the 5 and convert it into a 1. Okay. So we can do this by replacing R1 with R1 by 5. So we multiply 0.2 to the row, to the first row. Okay. And then the result will be, you will get 1, 0, 0, and I think the rest of the rows will remain same. So 2, 0, minus 2 and 0, 1, 1. And here on the right side of the bar, this will become 0.2, 0.2, 0 and then 0, 1, 0 and then 0, 0, 1. All right. Okay. So now let's see what else we can do here. So what I want to do further here is that I want to really get rid of this 2 here. Okay. And we can really get rid of 2 by so basically we take 2 times the first row, all right, and we can subtract from the second row. So in that case we will get rid of this 2, or we can also actually multiply row 3 with 2 and then add it to the second row. So that's the another approach we can take. So let me actually take 2 times the first row and subtract it from the second row. All right, so if you take 2 times the first row and subtract it from the second row, you're going to get so the first row remains intact, we do not change it, so it's 1 0 0, and now the second row will become 0 0 minus 2. All right, and this would remain the same, so 0 1 1. And on the right side now you will have 0.2 0.2 0, and then minus 0.4 0.6 0, and then 0 0 1. Okay, now since we want to convert this guy here, left side of the bar, this guy here, into an identity matrix, I don't like the term 2 here. Okay, so let me multiply row 2. Let me multiply row 2 with minus 1 by 2. Okay, so if I do that, let's see what's going to be the result. We'll get 1 0 0, and then this will be 0 0 1, and the last row will remain as it is, so 0 1 1. Put a bar here, and then the first row remains as it is, so it will be 0.2 0.2 0, and then the second row, if you multiply the second row with minus half, you are going to get 0.2 minus 0.3 0, and then 0 0 1. Okay, so remember, we are trying to convert the left hand side into identity matrix, so we need to have only elements in the diagonals of the matrix, right? So what we can do is that now we can actually further go ahead and swap these 2 rows. Okay, so if I swap row 2 and row 3, I'll get 1 0 0, and you'll get 0 1 1, and then 0 0 1, and here the right side you will get 0.2 0.2 0, and this becomes 0 0 1, and then 0.2 minus 0.3, and then 0. All right, and then lastly what we have, so now we have reached quite close here, right, to what we want. So all we have to do is to get rid of this one here. Okay, and then we are done. So let's subtract the last row, that is the third row from the second row. Okay, and then we will be done. So if I do that, so if I subtract the third row from the second row, okay, so we'll get 0 1 and then 0, and then we leave the third row as it is, so this becomes 0.2 0.2 0, and this will become minus 0.2 0.3 1, and the last row remains as it is, so 0.2 minus 0.3 and 0. Okay, and that's it. So we are done. So the matrix A has been made into an identity matrix, and at the same time the identity matrix here, this guy, got made into A inverse. So what you get here on the right side of the bar is A inverse, and you can check that. So if you multiply this matrix here with A, and where was A? I think we wrote down A originally here. So if you multiply A with A inverse, you are going to get identity matrix, right? So this is Gauss Jordan method of finding inverses, and you can do it for even for larger matrices. Okay, the process will remain the same. So you're going to convert. You're going to take a matrix A and write down the identity matrix, corresponding identity matrix, and then you're going to apply a series of row elimination methods or row elimination steps, elementary rows eliminations steps, to convert A here into an identity matrix, and in the process you're going to convert the I here into A inverse. Okay, so that's the method, guys, and I'll see you guys in the next lecture.